Good morning, my YouTube viewers. Crystal here. I'm just here this morning because I wanted to make you another video. I found out that it works out a lot better if I get up early in the morning and make a video, because at least I've got a good night's sleep, and then when I've got a good night's sleep, I can get up and make the video. But if I make the video like later in the day, then quite often I'm a bit tired, and so I might not do as good a job. So here we are. That's why I've got my camera turned off, because it's early in the morning. But I wanted to make this video for you on the wine recognition dataset. Now this wine recognition dataset comes from the sklearn library. And basically what they did on the wine recognition dataset is they standardized the values on the data set, so I didn't even get a chance to standardize the values. And as a result, because the values are standardized, I didn't really get a chance to do a lot of analysis. But what we'll do is we'll go ahead and go through the code review anyway, because there was a lot of information, interesting information in the code, in the data set, even though they had standardized it beforehand. So as I said, I got this data set from the sklearn library. So you don't even have to go out and look for data sets, because the data sets are in sklearn and you can practice on them. These data sets are called toy data sets, and I think they're called toy data sets because they're small. They're not very large, and because they're not very large, they give you the ability to experiment on them. I wrote this program in Google Colab, which is a free online Jupyter notebook, and it has a lot of libraries already installed in it. But one thing that I found out recently is that it doesn't have the most current version of sklearn in it. And one of the things that you need to do in sklearn is they've got a parameter called asFrame. Now that parameter called asFrame does not come up in the version number 22, 0.22, which is the version that is on the Google Colab platform. So if you want to use the asFrame parameter, then what you have to do is you have to install the most current version into Google Colab. So that's one of the problems that I've found with Google Colab. It doesn't actually have the most current versions of the libraries on it, which I find to be quite disappointing. But you can install those on the software pack, on the program. To give you a little bit of information about this wine appreciation dataset, this is a copy of UCIML wine recognition datasets, and then you get a link to where you can find it. And I did click onto the link and I did try to download the dataset, but the dataset in my computer, the dataset would not download into Excel. I did get it to download onto a Word file or a Notepad file, and then I was able to save it as a data file, and I was able to call it up, even though it had been saved as a data file and not a CSV. But that was on another program. That's not on this program, but I still felt the need to bring that to your attention. So the data is the results of a chemical analysis of wines grown in the same region in Italy by 3 different cultivators. There are 13 different measurements taken for different constituents found in the 3 types of wine. And then what I did was, because the data set wasn't named, the columns were not named in the data set, what I did was I gave you a cell that gave you the names of the columns just as a remark, really, so you know the names of the columns as a remark. So after I created my data set and after I created my program and I got as much information as I could about the data set, I imported my libraries. I imported NumPy, Pandas, Matplotlib, and sklearn. So NumPy is a library that lets you carry out algebraic functions. Pandas is a library that lets you work on data frames, and Pandas is written on top of NumPy. Matplotlib is a graphics library, and sklearn is a graphics library also, and it's written on top of Matplotlib. So now what we've done is we want to import the files. So we're going to import the files directly from sklearn. These files are automatically installed in sklearn. So that's a good thing because you don't have to go out and look for data sets to practice on, because they give you data sets in their program and their library to practice on. So that's a good thing. But the problem is, because these data sets are already in the library to practice on, you don't get the chance to do any data cleaning or anything like that. So I might pick a really bad data set and do a video and a blog post just on cleaning the data set, because that's one of the problems that you get using sklearn's data sets. All of the information is in there, so there's not an opportunity for you to impute any missing values, and there's not an opportunity for you to clean the data set, which is something that you would need to know how to do. And so those are some ideas for some more blog posts for me, like how to impute values and how to clean data. I'm sure I could get definitely 2 blog posts out of that. So the code to get the sklearn out of the sklearn dataset for wine out of sklearn's library is from sklearn.datasets import load wine, xy equals load wine, return xy equals true. And as I said before, in this particular program, the most current version of sklearn is not in Google Colab. So if I had wanted to, I could have done asFrame, and then if I had done asFrame, then it would have provided a data frame for me. But because they don't have the most current version, and I didn't really want to install the most current version and go through all that, I just used the xy equals true, or return xy equals true. So you've got your x. Another problem that we have with this data set is the data has already been standardized. It's not normalized, it's standardized. And so basically when the data is standardized, what they do is they take the median data, and the median data is at 0, and everything below the median data is a negative number, and everything above the median data is a positive number. So that's really what they did. Really, they just standardized it. And then you had the y value, that's your target value. It is separate from your the data frame. So you've got the x as an array of data, and then you've got the y as an array of data. So it's not really even a data frame. If we are going to make it into a data frame, and I'll show you how to make it into a data frame, but it really isn't even a data frame, it's just an array. Now we're going to do a little bit of analysis. We're going to plot a chart of y, which is your target, and y has 3 classes. So class 0, 1, 2, or 1, 2, 3, really, because that's what it says right here. It says 0, 1, 2. Okay, so it's got 3 classes, 0, 1, 2. The first digit is 0. And then I put it on a counter, and we said position 1 is 71, position 0 is 59, and position 2 is 48. So you have a little bit of a class imbalance, but not a major one. Now, I suppose what I could do is I could, the model that I used was multi-layer perceptron, so they didn't have the ability to balance it. But I'll show you what to do in a class imbalance. So we also put the X data frame on a heat map, even though the X data frame didn't have any column names. You could still see how the different columns relate to each other, how their interdependency on this heat frame. If you like heat frames and you like analyzing heat frames, well, the heat frame is here for you. And the next thing I did was I did a 2D diagram, and I decided to do that since there's not a lot that you can do with this data set. So I thought, well, it's going to be a good idea to make a 2D diagram. So I made this 2D diagram. I didn't have to standardize it. Normally, under normal circumstances, what you would do is you would standardize the data, but because the data has already been standardized, I didn't have to standardize it. But I got the mean and the standard deviation from this data. And I made something called feature columns, feature plus string I for I in range X shape 1. And then you can see the feature columns is 0 to 12, giving you a total of 13 feature columns. And then what I did was I normalized the data, and then I made that into a data frame. It says normalized equals pd.dataframe x columns equals feature columns normalized. So there, what we have done is we have taken the array and we have turned it into a data frame. So there is a difference between an array and a data frame. You can tell if it's an array because if it's just an array and it doesn't have any names at the top, but this is like made into a table and it's got names at the top, so you can tell it's a data frame. So now what we're going to do is from sklearn decomposition, import PCA, and PCA is principal component analysis. PCA wine equals PCA in components equals 2. We're only going to use 2 components because this is a 2D graph. So principal components wine equals PCA wine fit transform X. So we've got principal wine DF equals PD data frame data equals principal components wine columns equals principal component 1, principal component 2, and then you can see that it has created a data frame. So whenever it says PD data frame, you can see that it's actually created the data frame. And now we extract another piece of information. We say explain variation per principal component is 0.99809.123 and then a 0.00173592. And now what we're doing is we're using code to create the 2D graph. So you can see we've got the 2D graph. 0 is red, 1 is green, and 2 is purple. So you can see where all of the classifications fit on a 2D graph. Now what I decided to do is, since there wasn't a lot that we could do on this data set, I decided, oh well, what I'll do is I'll make a 3D graph as well. So I used the code to make a 3D graph, and this is your 3D graph here. So it's just similar to the 2D graph, except it's got 3 dimensions instead of 2 dimensions. So you can see where the data is fitting in memory a little bit better. You know, in memory, it's quite complex. It's quite interesting how this data fits in memory. And it also explains why maybe you don't get perfect. Maybe you don't get a perfect separation of the classes, because you can see how you've got 0 over here, and then you got 1 and 2 meshed together. And because you've got 1 and 2 meshed together, it's going to be a little bit difficult for the computer to decide which class is 1 and which class is 2. And that's why we have machine learning. So then what we had to do was we had to reverse what we had done. So we said x equals PCA inverse transform x. So we've taken x back to its original value. You probably could have been able to do x equals PCA transform, or 13, x equals in components 13 if you had wanted to, but I just decided to just inverse transform it. Now we take our x and we're going to split it for training and validation. So we split it for training and validation, and the test size equals 10. Stratify equals yes, and so that's because you've got different classes, and shuffle equals true. So stratify equals yes, attempts to it attempts to correct the class imbalance. That's the best way I can say that. It attempts to correct the class imbalance. And now what we're going to do is we're going to define the model. I decided I was going to use an MPC classifier. That's multi-layer perceptron classifier. So we're going to have 200 hidden layers. Activation is going to be logistic, which probably I shouldn't have done that. I can go through and use a different activation and see if I can increase the accuracy. If I use a different activation, that might help a little bit. So I can try that as soon as I finish this video. And solver equals LBFGS, that's for small data sets. Random state equals 1. Max iterations equals 15,000. Verbose equals true. Fit X train Y train. So we print our accuracy, which is 95%, but I might be able to improve the accuracy if I don't use logistics. So I might try to use a different activation and see if I can improve my accuracy. So I'm going to predict on the validation set. So ypred equals model predict xval. And then so you can see ypred, we have array of digits, and we only had an 83% accuracy. And then I put ypred on a counter, so you can see you had number 2, you had 7, 0, you had 6, and 1, you had 5. I put it on a confusion matrix because whenever you're dealing with classes, you need to use a confusion matrix just to tell you which ones you got wrong. So the confusion matrix tells you that position number 0, you got 4 right and 1 wrong. Position number 1, you got 5 right and 1 wrong. And position number 2, you got 6 right and 1 wrong. So that's your confusion matrix. So in your confusion matrix, you actually got 3 incorrect, which is why you got 83% accuracy. And then I made a data frame. You know, you see the PD data frame again. So the data frame allows you to compare the actual values against the predicted values. And what I wanted to do now was I wanted to make a diagram that shows you the predicted values against the actual values. And one thing that's interesting about this is it only had 1 yellow. So I think perhaps this diagram is only good for logical problems. It's not good for a multi-class problem because you only have 2 colors in it. And because you have only 2 colors in it, you can only tell that one was incorrect. So that completes this video presentation, and it was a good thing that I did the code review, because I found out one mistake that I made that I can try to correct to try to get my accuracy level up. If you like this presentation, please like, subscribe, and share. If you want to keep receiving notifications of videos that I make, then please press the bell button next to the subscribe button, and you will be notified whenever I make a video. And if you like the work I do and you want to support me, I have my email address to my PayPal account in the description box down below. The reason why I do this is because I don't have enough subscribers and I can't monetize. So as soon as I get monetized, then I won't be asking for donations anymore. And thank you so much for watching my video. I look forward to making more videos for you in the future, and I hope you have a very nice day.